Jai Hind everyone. My name is Anju Joon. I am the assistant professor in IT department. Today we will do the numerical on Booth algorithm. In the last lecture we have completed the concept of Booth algorithm, and as we discussed in the next lecture we will go for the numerical. So today we will do the numerical of Booth algorithm for the minus number. Okay. So the thing first we need to understand the flowchart of the Booth algorithm. So initially what we will take as an input. So whenever there is a Booth algorithm numerical, you will convert it into binary number, as we know that we will convert into a binary number. So there are certain things we need to assign the value to. That is, first is the accumulator. As we know, accumulator is a part of the CPU which holds the intermediate state of the operations, right? So we will take the accumulator. The number of bit will be same as the multiplier. Okay, and then there is one more thing, that is q minus 1, which initially we will take 0, but as we will go forward I will tell you how the value of the q minus 1 we will take. Okay, apart from that, in the B we will take the register in which we will transfer the binary number, means value of the multiplicand, and then there will be the multiplier, that will be the q register, and in that we will transfer the value of the multiplier. Okay, and then we will put the counter number, that is the number of bits present in the multiplier, that will be the n number of bits, and that will be the value of our count. So there are certain decisions we need to take. As I told you that there are two things I am taking. There are qn and qn plus qn or qn minus 1. There are two values we need to consider. So initially, as we know, q minus 1, that will be initially 0, as we have taken over here. Okay, now here matters what will be the q naught value. So always remember, when we are going in a q we are taking the multiplier, right? So the rightmost bit, whatever the bit is 0 or 1, there can be only two possibility. So that rightmost bit will go in qn value. We will take the bit as a value of the qn. So there will be two values, q naught and q n minus 1. So we will decide on basis of q naught and q1. If the value is 0, 1, so we will add the value of multiplicand to the multiplier. Simple, that we will add whatever the value is, we will do the addition. Okay, and that is, but if it is 1, 0, means the q naught will be 1 and q minus 1 will be 0. So what we will do, we will do accumulator, and in accumulator a minus b, means in the accumulator we will subtract the multiplier. But as we know, in computer, whenever we are going to subtraction, we always take 2's complement of b, and that 2's complement of b we will add to the accumulator, that is equivalent to a minus b. So we need to understand the subtraction will always be performed like this. And we know what is the 2's complement. 2's complement will be 1's complement of b plus 1. So that will be our 2's complement. So let's take one example also, so that if there is any student who is getting confused, so they can understand. So suppose the b value is 0, 0, 1, 0. Okay, so that is the value, and it will be minus b. How we will represent the minus b? So what we will do, there is b, so we will take the value of 1's complement of b, that will be 1, 1, 0, 1. In 1's complement, 0 converted into 1 and 1 converted into 0, and we will add 1. So it will be 0, 1, 1, 1. It is equivalent to 2's complement of b. So I hope there is nobody who is getting confused what is the 2's complement, if there is somebody. Okay, so now after we perform these two operations, there are two combinations is left, that is 0, 0 and 1, 1. What will happen when the bits are completely same? So in that condition, we will perform arithmetic shift, and that arithmetic shift will take place with accumulator, q naught and q minus 1. Okay, so for these three registers, we will do the arithmetic shift, right shift. Okay, and there is one more thing. So it is for the 0, 0 and 1, 1, we will go for the arithmetic shift only. But whenever there are the bits are different, first we will perform the certain operation. Either add, either subtract. After performing the operation, we will go for arithmetic shift again for the accumulator Q0 and Q minus 1. So these are the operations or the decision we will take on behalf of those 2 bits. And again, when we perform the operation, we need to check the value of the counter. So we will check, is the counter 0? If the counter is 0, we will take the answer, okay, that we will discuss further how we will take the decision. If not, so we will go back to the initial, means initial not for the initial initializations, I am talking about the decision box. So we will go there and again we will check the value of Q0 and Q minus 1. Again we will go till the counter value is not 0. So we need to keep in the mind that these are the things which we will follow. The flow chart, if you are solving, you are taking the flow chart, along with it you are solving the numericals. So it will be very easy to remember the flow chart as well as to solve the numericals. Okay. So let's go for the numerical also. So there are 2 things we need to keep in mind and it is important. So there is, I have taken the example of -9 and -13. So whenever there is a negative number, either in the multiplicand or in the multiplier, we need to take a note. If the number is negative, we will take value 2's complement of that value, either multiplier or multiplicand, and we will transfer that value to their assigned register, which we discussed in the flow chart. So as we can say, the multiplicand is -9 and the multiplier is also -13. So how we will do it? The number is negative. So what we initially do? So 9 will be represented as 1001. As we know, plus means we will take 0. Always you need to remember 0 for the plus and 1 for the minus. Okay. So what I did? Okay, I will take the magnitude only, that is 9. I will convert it into binary number, which is 1001. 1, 2, 4, 8. 8 plus 1 is 9. Okay. Plus 4, 9. How we will represent it? We will put 0. But the multiplicand is -9, means I will take the 2's complement of this plus 9 and that will be equivalent to our means 2's complement, and that we will transfer into our register. So I have taken the 1's complement first. When I am taking the 1's complement, it will be -9 and I will add, and that is 2's complement, and when I am taking the 2's complement of +9, that will be equivalent to -9. Now in a binary form, I do have the signed value which is -9. Now I can transfer it into BR. So let's go to the previous slide. So the concept will be clear. The multiplicand will be transferred into B, or we can say BR. Okay. So here I have transferred that value. So BR initial value will be 2's complement of 9. Okay. Now we need to check the multiplier value also. So there is also -13. Okay. First we will represent the 13, and that is 1101. Okay, 1, 2, 4, 8, 8 plus 4, 12 and plus 1, 13. Okay, plus 13 will be 01101. Now take the 2's complement, that will be equivalent to -13. Okay, this value will go into Q. As you can see, multiplier will go into Q. Okay, so what I have done? In the Q, I have transferred the value of multiplier. Okay, now go back. Accumulator will initially 0. Okay, the number of bits in both are 5. So accumulator will have value 0 with the number of bit of 5. So there will be 0, 0, 0. Okay, now we will go for Qn plus 1, or we can say Qn. Okay, means it is a, see, if I am taking Qn plus 1 is Q0, so Q minus 1 will be Qn. There is nothing to be confused. Okay, so initially what will be the value of Qn? That will be 0. Okay, so sorry, Qn plus 1, that will be 0. Okay, and that is what I told you, the qn will be this, and we will take the value of qn, and qn will be the rightmost bit of multiplier. So that is 1. Okay. So what is happening? Qn plus 1, initially we have taken 0, as here it is telling us, and qn will be the rightmost bit of the multiplier. So it will be 1 0. When the value is 1 0, so what we will do? In the accumulator, it will be subtraction of multiplicand. Okay, let's come over here. So we need to do the subtraction. Now again, see, accumulator equals to accumulator minus b. b is our multiplicand, या br हम यहाँ बोल सकते हैं br. Okay, what we will do? A plus 2's complement of br. Okay, now br is this, take the 2's complement, it will be same as your this value. So you can cross check that you are doing right. When you will take the, if you are having the negative number, you will check when I am taking the 2's complement of this, is it the same? Yes, it is the same. Okay, so a little bit of confirmation that we are doing right. So here it is that we are doing the subtraction. So what we will do? A plus 2's complement of br. So I would suggest you, whenever you are solving the Booth algorithm, always br and 2's complement of br. Okay, always mention it. So it will be easier for you. When you need to do the add, so you can go for the adding b. If it is a negative subtraction, so you can easily take the 2's complement. You don't need to take it out every time. Okay. So here will be the subtraction. So what we will add? 2's complement of b, which is 0 1 0 0 1. So 0 1 0 0 1 I have added. So it will be equivalent to, when I will do the addition, it will be same value of the qr. Now let's go back. I have done the subtraction. Now what I have to do? Arithmetic right shift. First I will tell you what is the arithmetic right shift. Arithmetic right shift is what? Suppose you are having a value, and that is a equals to 0 0 1, and you are doing the shifting. So this one will be go ahead, and that is 0 0. Now here comes which bit will come over. So it will always a copy of this value of the sign bit. So it will be 0. Okay. Suppose it was a equals to 1 0 0. Now how it will be? This will be go for the next 0 1. The leftmost bit was 1 sign bit. Okay. So it will be copied. This is called arithmetic right shift. So after that we need to do to complete the step 1, we need to go for the arithmetic right shift. Okay, we are going for that. So arithmetic right shift will taken place between accumulator qn or qn plus 1. Okay. So here come. Arithmetic shift will taken place between whom? This value, and this value. Okay, let's do it. So this one will go over here. Yes. This one will come over here. Yes. This, and this. Now this value will come over here. Now 0 0 1 0. Which value we will insert? Same value will be inside. Now we will decrement the counter. So that the counter was, the number of bit was 5. So it was 101. We represent 5 like this in the binary value. We will decrement, that is equivalent to 4. Yes, it is equivalent to 4. Now step 1 is completed. Now step 1 is completed. Is the counter 0? No, as we have seen it come to 4. The counter is not 0. We need to go back. Again we will take q and qn and qn plus 1. Okay. Now the qn plus 1 is what? It is 1. Okay. So it is 1. And the rightmost bit, that is also 1. So it will be 1. When both bits are same, what we will do? We will not do addition, subtraction or anything else. We will do the arithmetic right shift. Okay, let's do it. Same cheese. On this step, we will not perform anything. We will just do the arithmetic right shift. So, how it will be done? Let me erase it so it will be easier to understand. Okay. So, yes. Arithmetic right shift we will do. So, it will be, this one will go here. Okay. 0, 0, 1, 1. And this 0 will come here. Now again 0, 1, 0, sorry 1 and 0, and which will come? 0 will be copied. The second step is also complete. Decrement the counter, it will become 3. Is the counter 0? Still not, the value is 3. Again we will go. Now Qn plus 1 is 1 and Qn is, the rightmost bit is 0. What we will do at the 0, 1? It will be add. Okay. We will do accumulator equals to accumulator plus B. Now the multiplicand is 1, 0, 1, 1. Let me erase it completely. Okay. Now it is 0, 1. So we will go for so we will perform the add. Now the accumulator value is what? 0, 0, 0, 1, 0. What we will add? Multiplicand, and that is 1, 0, 1, 1, 1. So we will add this value, and when we will add, it will be 1, 0, 0, 1 and 1. Okay, addition is done. Is the step complete? No. We need to go for arithmetic shift again. Let's do it. Now we will go for arithmetic shift. So this 0 will go here, this, and this one will come over here. Now 0, 0, 1, 1. Now what will be the value? That will be 1, because this same bit will be copied. Now decrement the counter. It is 2 now. Is the counter 0? Again no. We will go for again. So this is Qn plus 1, 0. And what is Qn? 0. The bits are same. We will not perform any operation. We will do the arithmetic right shift. Let's do it. Only arithmetic right shift. So what will happen? This 0, 1, 1, 0, 1, and this 0 will come over here. 0, 1, 1, 1. And which bit will be inserted? That will be the same bit which was copied here. So it will be this one. Now decrement the counter. It will be 1. Still the counter is not 0. Again, this is Qn plus 1 I have taken, and this will be the Qn I have taken. 1, 0. What we will go for? Subtraction. Again, A minus BR, that is equivalent to A plus 2's complement of BR. Got it? So 2's complement of BR, we already have this. Okay, let's do it. Subtract. The accumulator values is this. We will add 2's complement of BR. We have added. Now the value is 1, 1, 1, 0, 0. Simple addition we need to perform. And then arithmetic right shift. That is we need to do. Okay. So it will be 1, 1, 0, 1, 0. This one will come over here. Now 1, 1, 0, 0. Same bit will be inserted, which is 0. Now the counter value will be 0. Okay. Now here comes a question, which registers we need to take for the final answer. So you will take the value of Q, QR we can say, that is 10101, and the value of accumulator, which is 1100. So it is equivalent to 117. Now there is one more thing which we need to understand. Here we will always check the leftmost bit. If it is 0, means the number is positive. Okay. When the number is positive, you will just convert the binary number into decimal and it is equivalent to plus 117. If you will multiply, it will be same answer. One need to understand, suppose if the value is minus 9 multiplied by minus 13. Okay. As we know, one is positive, one is negative. So, negative always wins. It will be minus 17. So, the answer will be a little different. How it will be? The answer, if you will solve the same question with the plus 13, you can solve it with the same steps I have told you. But the value of 13, we will not take the 2's complement. We will take directly because the number is positive. Okay. And we need to represent in the same number of bit as the value of QR, okay, multiplicand. Okay. So, we need to do it. So, what will be the value as you will go? It will be 10011010101. If you will solve it, you will get this. So, what will happen? If you will, certain things, it will not come same, I am sorry. It will be a little different. But what you will do, whatever the answer is, it can be something else. It can be. How you will do it? As you will see, the leftmost bit is 1, means the number is negative. So, you will put a negative mark. Okay. And for whole string, you need to take 2's complement. And when you will take the 2's complement, and then you need to convert it into the decimal number, and that decimal number will be your value, will be your magnitude. So, we need to understand, when one number is positive and one number is negative, so the number will be negative. So, it will always, the leftmost bit will be 1. And whenever there is a 1, you will immediately the minus, and for the whole value, you will take the 2's complement. After doing the 2's complement, you will convert it into the decimal number and you will get your answer. So, this is how you solve the numerical of Booth algorithm. I hope the concept of negative number, how we will take in the accumulator or the register before, because we need to represent it in the positive number. And in the last, we need to check the leftmost bit. Either it will be the positive number or negative number. Here, as we can see, it is a positive number. So, I will just convert it into the decimal and I will get the answer. But when it will be negative, which will happen always when one number will be positive and one number will be negative. Always. So, we need to understand the number will be negative and this binary string need to be converted into 2's complement. And that 2's complement will be your, you will convert into decimal and that will be your magnitude and that will be your answer. So, I hope today we have, I have cleared your concept of Booth algorithm, and we need to always keep in mind, take the flowchart along with it, and along with the flowchart solve the numerical. So, it will be easier and your concept will be very strong and clear. So, I hope you understood the concept, and Jai.